In today's telecoms and tech world, it can be challenging to monitor and maintain legacy networks while also ensuring seamless digital experiences and continuous connectivity. It can be particularly difficult to deliver services through hybrid cloud networks, all while using legacy management tools that are not fit for purpose anymore. Meanwhile, communication service providers want their end users to enjoy effortless and always-on connectivity, but they also can face a myriad of barriers. So this makes for a good time to look at what modern network monitoring systems bring to the table in 2024. And with that, in today's webinar, Network Monitoring in 2024, Disrupting the Status Quo with Unified NMS Telemetry, we are joined by two Kentik experts, Chris O'Brien, Senior Principal Product Manager, and Nina Varghese, Director of Technical Evangelism. In this session, our speakers will reflect on traditional NMS and the challenges engineers face managing hybrid cloud networks with outdated monitoring systems while juggling diverse telemetry. Chris and Nina will also give us an inside look at the Kentik NMS, the first AI-assisted zero-maintenance modern SaaS network monitoring platform, and they will shed light on how service provider network teams can improve services without increasing costs. But before we kick off the conversation with our experts, we've got a poll question for our audience. And here we really just want to explore your thoughts on your existing NMS. So let's have a look. And here we go. So you should have a window pop up on your screen asking you, how happy are you with your current NMS? And the options are very happy, somewhat unhappy, and very unhappy. So if you would like to make your selection and choose your answer, we'll give you a few minutes. Sorry, not a few minutes, a few seconds to answer. And then we'll push the results through. So I might invite at this point our speakers to join me and unmute your cameras and your microphones. And perhaps while we still wait for everybody to answer, you might want to, let me know what you think. Most people might be saying what you expect to see in the results.
Yeah, I'm really curious. We found some people that are happy and some people that are unhappy. I don't want to overly influence the results, but for me, it's super interesting to understand where you guys are coming from, and that will help us understand, what to share more in the presentation, depending on where you are in your journey.
Perfect. Yes, that really would help, wouldn't it? Okay, so we've given it a good more than 30 seconds. I'm going to push the results through now. And here we go. Most people are somewhere in the middle.
Oh man, that's almost a perfect split, right?
Yeah, yes. So somewhat happy, somewhat unhappy. I'm going to completely hand over to you, Chris and Nina. And here we go.
Yeah, thank you. Yeah, I actually wonder if the somewhat unhappy, very unhappy is like 50% might have to do with missing features in their NMS system. I remember when I was working at an ISP many years ago, we were having a fully homegrown system. And so keeping up with new features in the network or new request of what we needed to monitor could be hard for that one person who was operating or building that system.
Yeah, it's a tough choice, right? With homegrown, you get the benefit of kind of creating exactly what you want, typically jumping off from some sort of open source platform and then heavily customizing that. That's especially good for service providers where you're making it match your own workflows and the data points that are important to you. On the flip side, it's typically just a lot more laborious to build and maintain. So what I've seen is that enterprises, folks that use either enterprises, which tend to use a commercial solution, or service providers that choose commercial, they tend to have a lot more features, but in a lot of cases, that's just bloat for them. So it's really about figuring out what is the match for what you need.
Yeah, I agree. I also wonder if this increasing need that I heard we have for streaming telemetry might also affect it, because that was definitely something that I could imagine would strain on a homegrown and home maintained system. You're getting the data in so much faster. You have more data points you need to save. And is that worth the benefit of what you get when you start using streaming telemetry?
Yeah, that's one of those newer features that can be hard to get from a homegrown system. I think we ought to jump into it. Maybe in the way of quick introductions. I'm Chris O'Brien. I was a network engineer for about a decade. I started a ISP and then spent most of my career in enterprise as a network engineer. Then I spent a decade or so working on building software tools for network engineers. And that's what I do over at Kentik. And we're going to be showing you a bunch of this functionality to try and address some of these challenges that we've been hearing about. Nina, you want to give a quick intro?
Yes, I'm Nina Bargeson, and right now I work as what we call service subject matter expert on everything service provider, basically, at Kentik, helping develop our tool for that particular market. And I used to work very much in the peering, but also in a planning function, previously at an ISP. And I am not so much a tool builder, but more I need this in the tool, build it for me, please, or go out and buy it. So that's why we can have this conversation here today, I think.
Yeah, you're way, way deeper than I am in service provider technology and understanding that side of it and operating it. That's for sure. You mentioned streaming telemetry. I'd love to talk a little bit about that. I think there's been a lot of sort of hype and discussion about streaming telemetry, which we don't see a ton of people using it yet.
No, and why do you think that is? Because when I sort of just hear the sort of top level, what's the benefit of streaming telemetry? It is like, well, you get instant data. I mean, how can that not be good? So why is not everybody using it right away? Because I remember using SNMP during like a maintenance window, and we had to sit and look at counters at the routers to make sure that we did not mess something up more than we were trying to fix when we did the thing.
So maybe we break that question down into like, what are the benefits? And then if this is so great, why are so few people using it? Does that make sense?
Yes.
Okay.
That's
so
benefit.
There's a number. Streaming telemetry was invented SNMP was invented in 1988. I don't know if you knew that, Nina, but it's been a while since we're going on 40 years. Yeah. And 40 years is not like in technology terms, that's very, very old. Like if I was the SNMP protocol designer, I would be completely satisfied with my contribution to the technology world. Imagine designing a protocol in 1988, and it is still by far the most prevalent protocol for that purpose 40 years later. That's incredible. But as we all know, there's a lot of limitations with SNMP, and networks have changed a lot. And so streaming telemetry came along to be a better fit for today's networks. And what you get specifically is the biggest thing is that streaming telemetry is subscription based. So the nature of a SNMP data collection is the SNMP manager sends some question, asks some question, and sends it to the router or other network infrastructure. And that network infrastructure sees the question, prepares a response for that question, and replies. That is very different from streaming telemetry, where streaming telemetry requests the management system, or actually either system, can say, hey, I want this data and send it to me every 5 minutes, for example, every 1 minute, every 1 second, whatever that interval is. And then the router just schedules that in with its other work and prepares those data points to be sent over at a consistent interval. And that's the biggest difference, and that makes it way, way more efficient. I mean, the way that everyone has been using SNMP since the early 90s, at least, if you think about RRD tool and MRTG and Cacti and all these things, is like, we're going to ask this. They're good tools. So we're going to ask that SNMP, that question via SNMP, like the total out bits, on an interface. We're just going to ask that every 5 minutes until the end of time and draw a graph of the rate, right? And so being able to do that as a subscription instead makes it way more efficient. And so the problem that's solving is, for a lot of folks, particularly with large chassis, you try and do faster polling. Like, the most common polling I hear is 5 minutes. You try and get down to even 1 minute polling, which, to be honest, in 2024, like, there's a lot of time between each data point in 1 minute polling. But when you do that with a chassis with hundreds of interfaces, and maybe you're pulling several metric series per interface, it just starts to overload the device. And so you miss polling intervals, or you start to see high CPU on the device. SNMP just does not scale well for these systems. So what that means for most people is they push the interval up. So maybe they go back to 5 minutes, even though they want 1 minute. Maybe I've talked to folks that have pushed to 10 minutes when they're on older gear that's got a whole lot of interfaces. And so having Streaming Telemetry do that subscription, much more efficient data collection, means you can do much more frequent data collection, which means like much higher granularity data for analysis.
Oh, that makes sense. Then you don't have to sit on your router when you do maintenance, for instance.
Yeah, that's right. So that high granularity is like, I can show you, maybe I can show you some of what I'm talking about here. I'll just share my screen.
Because on a router, you're not seeing anything visual. And I mean, some people love just to see numbers go up and down, and that's the metric they like to see. But to me, I kind of need a graph like this one, for instance.
Yeah, you want to know where you are based on where you've been, and so graphs are super helpful for that. And this is something I've told so many non-engineers, but the amount of data that a network engineer will get out of a graph is incredible. They see all sorts of patterns through their years of doing this analysis, and so you present a graph, and you're really presenting a lot of information to an experienced network engineer. But what we can see here, we're just looking at an example of CPU on this device, and see this is collecting once every 5 minutes. We've got data points here, and we see around the middle of the time at 3 or so. I say or so because it looks like 2:55. We've got like a 10-minute span of time on either side of this high point here. But this high point spikes up to 4.5%. So this is the most common polling interval I see with SNMP, is every 5 minutes, and we see that picture. If we switch that same data, but much, much more frequently, as Streaming Telemetry supports, going every couple of seconds here, we can see that wasn't a spike to 4% for 7 minutes. Yeah. That was a spike to 59% for, looks like a 6-7 second period, right? Which is a completely different conclusion. Like, these are telling you a different story about what's going on.
Absolutely, yes, I see that. And so do you get this with some sort of delay then? You see that, this happened 4 or 5 minutes ago?
Yeah, the freshness is another really interesting thing, right? So high granularity when you're doing analysis, but this also helps you a lot when you're looking at ongoing problems. So I've got that same device, and we're polling or subscribed to CPU every 2 seconds. And so we've got our history here, as you see, and we've also got this live chart. And we can see these data points are being loaded in every 2 seconds. Not sure if you can see the timestamp there. Every 2 seconds, we're getting a new data point. So I don't know about the teams that you worked in, Nina, but for the teams that I worked in, definitely like, if you're having high CPU, you want to jump into the device and you want to troubleshoot the issue, and that gives you real time.
Right away. Yeah.
Yeah, you want to fix it right away, and there's very fresh data that you can see on the device to troubleshoot, but you typically get notified of the problem by the monitoring system. And I feel good again when the system that told me things were bad, when that tells me things are good. So not just the router, but when the monitoring system goes green. That goes green is where I get my comfort from when I'm in an outage, right?
Yeah, exactly.
Yeah, and so I see we have high CPU here. Of course, I just triggered that problem. That's not just a good timing.
Yeah, I see that. Yeah.
We have high CPU here, and you can imagine you log into the router, you run show process, you figure out what process is taking that high CPU. Maybe you read up a little bit about what could cause that process to take high CPU, and you look through your configuration, and you come up with a hypothesis about how to solve that problem, and then you implement some sort of change. And then you're sitting and waiting to see if that change worked or not. When you're using SNMP at 5 or 10-minute polling intervals, you're talking about waiting 5, 10, 15 minutes. You sometimes have to wait 1 polling interval. Sometimes you have to wait 2 polling intervals to be confident in that data point, right? So 5 or 10 minutes is, man, it's just ages when you're sitting in an outage, and maybe you've got a couple of things to try, not just one. So with streaming telemetry, the data coming in as so fast here, we can do something like, maybe I'll put in an intervention. I'll fix this high CPU now, just made that change then, and we'll see how long it takes for that to show up in the graph all the way, make it all the way from the device into our browser. There it is. So now we're back down to 1%.
Yeah. That certainly, I mean, it means we'll drink less coffee when you're on a maintenance, but it will also means that you are more comfortable faster. And then maybe you don't need that much coffee. So,
and seeing the data come in like this quickly is a big reminder of how delayed our monitoring systems typically are, and how we just kind of take that for granted, right? That they have to be that delayed, and they don't have to be that delayed anymore.
Yeah, no, I know. So how come everybody's not using it already?
Yeah, right. If it's so great, why isn't everyone using it? And I would say of the people that I speak to, less than 5% are using it. So I've talked to a lot of those people, and I think it has to do with where streaming telemetry came from. Streaming telemetry came from the likes of Google and others, these giant people running, the top 2, 3 largest networks in the entire world, and how they want to deal with their network. They saw SNMP was not a good fit, so they put on a lot of pressure and said, hey, here's what we need. It needs to look a little bit more like software. It needs to be higher, more efficient, all of these sorts of things. And we're going to wholesale cut over all of our, white boxes over to this software, and we'll write some of this software as well. And the on the tooling side, and then the network infrastructure folks, they need to get it support on their side if they have any chance of selling us hardware. And so the network vendors scrambled to do that because these accounts are giant accounts. The challenge is there's sort of an assumption there that the folks that are making tools for implementing streaming telemetry are making tools for networks that are going to do a cutover from SNMP to streaming telemetry. That's a crazy idea. For the vast majority of networks, they have gear that's 5 years old, runs great. There is no business justification to replace that gear. Maybe not now, maybe not for another 5 years, maybe even longer, right? If that gear is functioning properly. And so you have equipment of various ages, and only the newest stuff supports streaming telemetry. So how could you migrate your entire network over to streaming telemetry? It just doesn't work. And so I think the trick, what will unblock that capability is being able to use streaming telemetry right alongside SNMP, with SNMP still being not just like a protocol, but a first-class citizen, a peer of Streaming Telemetry as a first-class citizen for how we collect and analyze data from our network.
Right, right. So if only somebody could build that tool, eh?
Sure, right. So we talked to a lot of people operating these large networks about the challenge and heard that challenge, and so we've taken a stab at solving it with Kentik NMS. And so maybe I'll show. What do you think? Maybe I'll show some architecture so you understand how that works, and then we can jump into the UI and look at how this data shows up together, the SNMP and Streaming Telemetry.
Yeah. So let's talk about the architecture first. I mean, what is it that we do?
So for some reason, I'm not seeing the slides pop up. We want to jump to the first architecture slide if anyone listening can do that. Oh, I see it there. I just wasn't looking at the right thing. Okay, great. So we have a data collection little piece of software that runs local to your network. When you're doing SNMP, you don't want the internet to initiate SNMP to your local network's infrastructure and have administrative credentials. That's no good. So you install a little piece of software local in your network. That's called the Ranger Collector. And then that will talk to, in our case, the Kentik cloud to understand what devices the collector needs to collect data from. You have this function, these flat files, they're plain text files called collection profiles. And this is where you configure data collection, like device support sort of things. So what protocol am I going to speak, and what data am I going to collect? And this collector speaks a number of different protocols. We really designed it to support all of the protocols that are on the screen. Today, we support SNMP and Streaming Telemetry. And then again, the architecture, these collection profiles are specifically made so that we can sort of be collection protocol agnostic and just collect all of the data. And we normalize that data. There's some built-in functions, but for advanced use cases, you can use a Skylark, which is a Python-based language, a lightweight Python-based language to normalize any data you collect from any of these protocols. And then that gets sent over to Kentik Ingest, the same way that we collect flow data and do terabytes and terabytes worth of data there. We collect those metrics, and of course you can deploy multiple of these collectors, and this is all sent to the cloud that are ingest via influx line protocol. So there's some really good other collectors like GNMIC and Telegraph that can get data points for you and export via influx line protocol. So because they're using, again, that influx line protocol, and we've chosen to use the same, we can ingest those data points as well. So this gives you like a very broad way to collect data, across a bunch of different protocols. And then also these collection profiles give you a way to parse and normalize that data before sending it up into the cloud. Once it's in the cloud, then it becomes accessible for all of the tools in the UI, our query builder, our alerting engine, our dashboards, all of those sorts of things.
Nice. Yeah. Did you want to show us?
Yeah,
do you want to show us how that looks in the tool?
And show that in the tool. Let's jump back to the same place I was. Okay. Okay, so you can see that we have this new network monitoring section that's part of our main navigation here. And maybe I'll jump to the device list. There's a whole bunch of devices here that we're monitoring. Maybe I'll take a look at this specific device. Now we've got some interesting data here. And so all of this data, is coming from either SNMP or Streaming Telemetry. It doesn't really matter because the data is normalized, right? So the the look of it is the same regardless. That's really important for us. Every dashboard, every alert, all of those are built to query this normalized data model. So as an operator, you don't have to care where this data comes from. Your dashboards will be comprehensive, include all your devices. Your alerts will alert on CPU going high for one device using SNMP the same way they would on another device using streaming telemetry. And you can drill into any of these data points. Maybe we look at this CPU, and that's going to bring up Metrics Explorer, which is our query builder, right? And so we can see we have a lot of fine-grained control over the query that we're performing. And because you're used to looking at a dashboard, and there's typically in an NMS, there's some level of drill in here, but by being able to click in and go to this quite comprehensive query builder, you really have a lot of fine-grained control over things that you wouldn't normally have control over that service providers find useful. These are things like, how are we doing our aggregation, average, P95? Are we preventing any aggregation? If we are doing aggregation, what's our sample size? All sorts of things of that nature. But we've got the CPU here, and this section up top allows us to kind of navigate through our entire data model. So open up measurement. This is based on OpenConfig. OpenConfig, we believe, is the way of the future in terms of data models. So we've normalized all of this SNMP, API, all sorts of different data and of course, streaming telemetry data into this one data model, and you can just see that here. So
wow, that is a lot of different things. Is there any help to sort of find our way around in that if you can't hold the whole data model in your head?
Yeah, I mean, you can certainly search here. That tends to work pretty well. So I know a lot of folks are familiar with interface utilization charts. So maybe we just build one of those to show what that looks like. We can do that, from scratch here, or change completely from this query to that query. So we'll look at interface counters, and then maybe we want to look at utilization. So we'll do in utilization and out. Of course, we've got quite a bit of different data series here we can select from. And what folks are used to is you want to look at that by device name and by interface. So we'll just run that query. I can see that's area visualization. I don't like that. I want a line chart. So here's an example of seeing all of those different devices, most of them at 0%, but two outliers here at around 20%, all of their CPU utilization using that query builder.
Yeah, that could be useful if you know, but it doesn't really give you a lot about what the amount of traffic is. So can you add that as well, sort of the bit rates?
Yeah, sure. So in and out utilizations, maybe percentages, maybe we care about in utilization and in bit rate. And we want to show, yeah, this looks fine as it, oh, here we go. Yeah, maybe we'll have the in bit rate charted up here. We also we've got just enough delay to walk over each other and chatting a little bit. Nina, I'm sorry.
Yeah, sorry about that. Yeah, I was just going to say, you've got to remember the P95 because that's really what we care about, right?
Yeah, for a lot of providers, P95, P98. And so here we see that in bit utilization, looks like we need to change that to megabits per second in this case. And then we also, and of course, this is our lab, so these are not large amounts of traffic. And then you see below, we're showing the min and the average, P95, and the max across this whole period. So a lot of fine-grained control. But the main takeaway here is that you've got this normalized data model, and now when you're doing those queries, as I'm doing them here, you're getting your SNMP data and your streaming telemetry data right alongside each other. You don't have to, there's no extra mental load. It's not a separate system. It's not a separate feature. It's all in the same spot. And the same way we do it here is the same way we do it for dashboards, for alerts. It all just works. You're working with a normalized data model. You're not working with SNMP or streaming telemetry at this stage once it's in our UI.
And that means you can do that slow transformation of your telemetry towards streaming telemetry as you upgrade your network and have another box come in that supports it and take an old box out that doesn't. You can move that over. That's making it a lot easier than a big swap from one day to another.
Yeah, and a lot of folks that we're working with will just deploy it on a couple of systems, or maybe they do an overhaul of a specific part of their network or deploy a new POP, or maybe they just install one device, upgrade one device, and they try it there. So it's really a minority of their network that is using it. Of course, the devices that you're replacing and that are the newest and most advanced typically are very important devices in your network. So oftentimes you're getting those first devices in some of the most important places. But in any case, easing into it, I think, is the way that we're going to all get more streaming telemetry benefits.
Yeah. Yes, I agree.
So I'll stop sharing here. I know one of the other things we wanted to talk about is how you collect, visualize, and alert on custom data points for, like special use cases. Have you experienced that in service providers, sort of needing to get specific data points that the NMS doesn't include out of the box?
Yeah, well, so we didn't really have any out of the box, but we were very, very extensive in sort of thinking, oh, I need this data now. So for instance, at some point, we wanted to try and do some fault modeling on our backbone. Mm-hmm. And so that we needed to collect interface counter traffic data from the LSPs, the MPLS LSPs that we had in the network. So we were trying to sort of get the NMS system to do that, and just even doing it here in our custom built own, it was not a very easy task. But that was particular a use case where we want a traffic matrix, like all the traffic go from A to B, put it in a matrix so we can model on that one. So that's only one use case where I'm quite sure that nobody was able to do that for us at that time.
Yeah, I think that's one of the more common things that drive service providers to like homegrown solutions is adding those custom metrics that none of the commercial solutions support. We've focused quite a bit of time on that in the design process. So all of the device support we have today, we're not programming that with a programming language. We're configuring that inside of those collection profiles. So that's where you specify what protocol to use, what data to collect using that protocol. And then there's a number of, I touched on it earlier, there's a number of built-in sort of transformers, bits to bytes, and common things like that. But you can also pass that data over to Starlark, a Python-based language, to otherwise parse and whatever you need to do to that data before then sending it over to your NMS system. So it's quite a, I guess we're trying to hit in the middle, which is to say you don't have to be a programmer to do it, but you get a lot of the extensibility benefits that you would, if you were programming it directly. It's just a lot faster to do because a lot of the framework's already there for you.
And I think that's good transformation for somebody who's used to build their own systems, right? If you get a system that is that flexible, that you can customize yourself, that gives you a lot of opportunity to to get those particular things done. Yeah, because I'm thinking in modern networks as well with segment-based routing and a lot of, you color the links in different colors and move traffic around automatically. There's a lot of need to also monitor that the traffic is flowing the right way and not just getting an alert, oh my God, we filled the link somewhere, if we don't know what's actually going on with the traffic flowing through the network. So
yeah, that's certainly the case. That's been, I guess, Kentik's bread and butter for a long time is understanding traffic flow. We've been really careful to make sure that we correlate these two data sets together because we do spend so much time thinking about flow. So, if we, I suppose I need to share again, huh? I can show you what that data correlation, some of the points where that starts to show up in the NMS here. So jumping into this device again, we've got a lot of data from NMS on this dashboard screen. If we go to the traffic tab, if the device we're looking at is exporting flow, then we'll be able to see traffic. The traffic tab will show up. You'll be able to see traffic here. And you've got the same sort of controls that you normally would inside of Kentik's flow capabilities here to slice it by all of these different ways. And if you wanted to, you could drill into, like the full fat view of Data Explorer, where you've got all sorts of different controls for how you do these queries.
Oh, yes. And that's one of the things I really like now about extending our tool to, look at the network health, like the device health, and look at our traffic health at the same time. So we can sort of correlate those and also do that in when we're looking at figuring out why something is the way that it is.
Yeah. So like this is one device. Oftentimes you want to see that in a dashboard view. Maybe you build a dashboard for a certain application or a certain network location or what have you. You can do that on the dashboard views as well. So combining like the map views with the device availability that comes from NMS data, active alerts. Maybe you have your quintessential high utilization interface charts, BGP prefix counts. We've got some synthetic stuff here from our synthetics product and traffic right alongside that. And so in this dashboard, you can add these widgets and configure these widgets from all of these different technologies and sit them together and start to correlate. It's about synthetics and flow and NMS data is all very different perspectives on your network, right?
It is, but it helps you create that holistic view that, we're used to the engineers getting that doing that correlation in their head, right?
Yeah.
So like, I'm going to look in this system, I'm going to look at that system, I'm going to look at this third system, and then it all falls together in your head, and you go like, oh, I think this is where something is wrong or not good. So.
And I know we have a team that has been working on like a bit of an innovation lab where we're trying to work on some of that correlation stuff. Journeys is what I've heard. I know you've been working pretty closely with that team. Would love to understand more about what you've seen.
Yeah, I can show you sort of a overview that turns into a debugging sequence that I have done. So yeah, you see my screen here now. So I'm just on the front page of the tool right now, and I find journeys by just going into the menu as well. We call it a preview because this is very, very early in the in the journey of journeys. So, but what we've been working on is actually using natural language and being able to use natural language while we're diving into the data and not thinking about what kind of data it is. So now imagine I'm getting to work one morning, and I'm a traffic manager, and I would just want to know what happened with my network last night. So I just want to look at the top source ASNs over the last day, because it's since I looked at it the last time. So did I get it right? And what we've done is that we have implemented a large language model, like everybody else, so that we can just ask questions using natural language and get results from the data in our tool. So what I got here is the top ASNs, and then I'm just remembering I only want to look at what is going on over my network edge. So I'm just going to ask, am I still sharing?
Yeah, the share seems to have gone away all of a sudden. Might need to reshare there.
I'm just going to do that again. Not sure why that happened. Probably me who did something. So we're back in the window now. So yep. I'm just going to add a network boundary external, because I only want to look at what's going on over my external boundary. And you notice there's a little syncing. That is the language model translating into the data, into the query, and then the next is the query loading. And I see, okay, it's a little bit less traffic. It's kind of the same ASNs. That's nice. I wonder what sites it comes into, and I wonder what kind of traffic it is that comes in. So I'm just writing.
It's very conversational, right? Like you started with a query, and now you're sort of adding to that query while still having the context of the original thing that you asked for. You're adding on top of that, huh?
Exactly. It remembers, as long as I'm using the right keywords to sort of go add or remove, or sort of just conversational, we are still talking about this thing. It will just add that using filters. Like here we can see there's a filter. I'm pointing at the wrong screen. This is why there's a filter, and showing the kind of the filter I added in the previous query. And now you see I get a lot more broken down by a lot more different dimensions. And actually now I kind of lost the overview. So let's have another visualization instead to get a visualization that will give me information. So again, waiting for it to translate. It's not super fast today. And here.
So in the background, it's like it's taking the natural language, the show as Sankey, and then like I've used Data Explorer. It looks like that it's translating that into a Data Explorer query, and then running the query and showing you the results. Do I have that right?
That's exactly what it is. It's you can see that down here that we are in Data Explorer, and I'm just not getting a Sankey diagram this time. That's embarrassing, but again, this is I'm going a little bit more extensive now.
So I know we have a huge number of like filtering options and grouping options and visualization options, and sometimes it's hard for folks to find all the different things that they want to do there. So this is like an easier way to enter into that, I suppose.
Yeah. Oh, there we go. Now we got the Sankey diagram. And again, I needed a little bit extra massaging this time. And here we see, again, pretend I am the network manager. I'm looking at my traffic. I go, oh, nice. A lot of this traffic is customer traffic, but that's not really what I'm most interested in. So let me remove that. source. Good. I'm just trying to spell at the same time. The great thing is that I've noticed that most of the time it will also correct my spelling errors, which is really useful for people like me who speak too much.
Yeah. And, you're in the heat of the moment. Sometimes the letters aren't perfect when you're typing.
Exactly. So, come on. And you notice now there are two filters. So I added another filter, and then I get this overview that I was looking at before. And I notice, oh, wait, Google looks like it's coming behind other providers, but I know that I have a direct peering to Google. So what's going on with my traffic? So what's going on with that peering that I know I have for Google? BGP enable with peer AS. And remember, now we've been working on refining the same query in Data Explorer, which is the flow traffic. The flow traffic, but I want to know something else right now. And it's working.
Yeah, I know with BGP neighbors with the NMS, we collect the neighbor, discover the neighbors, and collect the relationship status.
Exactly. So I was just asking, what's up with the state for peers that who are Google AS, and there's the explanation for why I was seeing the traffic through behind the providers. It's the session is down. So now I can go and yell at somebody and say, hey, why is our session to Google down? That's not great, right?
Yeah.
So, yeah. So this is just one way that we're still doing the correlation a little bit in that it is me getting ideas from the results of the previous query. But the beauty is that I can jump around into the tool wherever I want to jump around. And I'm just, there you go. And eventually some of this can be automated, right? I can also I can save the queries that I just did, or the questions that I make. I can save that so that somebody else can just go in and then get all the queries up at the same time. I don't have to go through the same thought process that I went through.
Yeah, I see. Yeah. I mean, so many of these, whether you're troubleshooting or you're analyzing, it's a series of like, okay, so I know roughly about the problem. I'm going to start asking questions, look at the answers, and then I'll understand the problem a little bit better. And then I'll have a new question. So I'll ask that question and I'll just keep repeating through that. So the idea of having a single interface to do that, where you're not navigating through tabs, that's pretty interesting. And then of course you can just scroll back up. You're like, oh, what was the answer to this one question? And you can compare that data point, right?
Yeah, exactly. So I think it's going to make life easier for a lot. And I have to say, I think it's addictive. Once I've started using this part of the tool, whenever I go over to the explorers, either Metric Explorer or Data Explorer, and I have to sit and go through the query tool, it becomes a little bit tedious because I've gotten used to just writing sort of like, and eventually I'll just, learn to speak clearly enough that I can talk the question into the tool, but we're not quite there yet, but I see that happening soon.
Yeah, and I knew there was a question about costs, and we'd planned to talk about pricing and cost a little bit too, particularly for service providers tend to run very large networks, and they're trying to do so profitably, and the profit margins typically aren't large, so you really need your tools to be economical. And one of the things we learned when we were talking with service providers before we built this tool, or as we were building it, is most NMS will charge based on interface. People really don't like that because when they have a device like a chassis that has 300 interfaces or 700 interfaces, they're paying a huge amount of money for that one device, and that feels a bit unfair. A lot of other NMS will charge based on device, but then you're paying the same price for the chassis, which I suppose feels good, but you're paying that same price for something like a tiny router that's sitting at the edge of your network, or even a autonomous access point for wireless ISPs. And so that feels super unfair because it's so much money for these tiny devices. So we thought about that a lot and decided that we would charge by capacity. So very similar to our flow tools, which charge by flows per second. NMS, we charge by metrics per second. And what that means for a service provider is they can say, you know what, I care about my interface utilization, I care about my errors and discards, my bits in and out. Maybe I don't care about my broadcast packet count. Some providers care a lot about their multicast packets, some don't. And so you can really tune and tweak all of those different things to collect only the data that you need. And when you collect that data, you can control how fast you're collecting it. Like, am I collecting this once per second, once per minute, once per 10 minutes? And in those ways, you can really align your data collection with where you find value as a company. And then the net result of that is, in a system where we're charging for metrics per second, say it's, bits is the metric and you pull every 5 minutes, then that's very few metrics per second. If you pull it every 1 second, then it's 1 metric per second. So you have a great deal of control to align business value with what you're paying for. And I think that opens the door up to folks that have historically been kind of priced out of using a solution like this to make it plausible, at least to see what that would look like for them.
I think you're right about that. Yeah. And I think you moved a little bit slowly into a Q&A now, right? I think.
Yeah, we had to jump to our Q&A, huh?
Yeah.
Yes, thank you so much, both of you, Nina and Chris, for that excellent and insightful discussion. Let's move into the Q&A. And yes, you've already answered one of the questions. I'll move on to the next one. One of our audience members would like to know which information you expect from local inventory linked to GNMIC.
So the main function there, I think you're referring to the local inventory that you saw in the architecture slides. What that's talking about is, rather than having each agent be configured for what it needs to pull, you configure the SaaS application with all of the devices that you need to pull, and it sends that down to all of the individual collectors that collect that data. So you can sort of centrally manage and scalably manage the inventory of all the network devices you need to collect, even though you've got maybe a fleet of collectors that go and do that out in the field. Hopefully that answers your question.
Super, thank you, Chris. Okay, and then the next question is, which industry vertical will benefit the most of this set of new tools or slash methods?
Yeah, I mean, I would say the earliest adopters are the folks like Google and so forth, but the sort of tranche of adopters after that who are getting the most value out of it are like digital businesses. These are all of the biggest brands that we're familiar with. So not calling out any specific customers of ours that we may not have the privilege to do, but if you think about the biggest brands that are distributing content and you're interacting with their applications on a day-to-day basis, those are the folks that tend to need more frequent data points, and that's their business's lifeblood. And so they've been jumping into streaming telemetry first.
Okay, super. Thank you. I should have also mentioned earlier, there is still time for our audience to submit questions through the Q&A console. And we still have a few questions, so I'll just run through those. So the next one is asking whether this is a SaaS or on-prem.
Yeah, so this is a SaaS tool, SaaS first. So you deploy it in our cloud. You can set up super fast. A lot of times folks will get data coming in about their specific devices, see their devices in the interface in like 5 minutes, which is pretty great.
Okay, fantastic. And then what polling intervals are supported?
Yeah, so by default, we do 1 minute polling. I think that's the right choice for 2024, but it's configurable. You can do 5 minute polling, 10-minute polling, down to 1 second polling.
Okay. Thank you. And then is there an API for this?
Yeah, so we've done a lot of API at Kentik. That's one of the main ways our customers interact with us. With Kentik NMS, we're quite early, so we don't have as much API as we want yet. We just finished the API to query, do like a metrics explorer. We saw we were doing queries and seeing data returned. We just finished the API, so now you can do those queries yourself. We are actively working on a device API, which is to add, remove, update the configuration of NMS polling for a given device. That'll be out this quarter for sure. And then a number of other, less commonly used APIs. So I would say we're midway through that right now.
Okay, fantastic. Thank you very much. So that's it for our Q&A section of the webinar. And with that, I'll be drawing the proceedings to a close. If we didn't get to any of your questions, rest assured they will be forwarded to our presenters who may well reply via email. And I would like to one more time thank our presenters, Chris and Nina, as well as Kentik for making this discussion possible. Big thank you also to our audience attending, engaging through the Q&A. And it would be great to see you at the next session. Goodbye.